number 3. So this would be the first of the non-calculator questions. And so there's a little bit of arithmetic on this, but you really don't need a calculator. So, of course, the first thing you want to do when you get your free response question is read the problem and look at the graph and make sure you understand exactly what the graph is representing and everything that you need to know about the graph before you begin. This information in the introduction paragraph here, every piece of information that's in this paragraph is there for a reason. So as I read it, I'm going to think about each sentence and what it's telling me about this graph to help me better interpret the rest of the questions. Now, as I look at this question, it strikes me that this is probably a really good question for the exam that you're going to be taking this year. They're going to want to focus on problems that are very conceptual on your exam this year, as opposed to you just showing you know how to integrate or you just showing you know how to take a derivative. They really are going to be focusing on questions that are about interpretation, questions where you can't just open another tab in your browser and Google how to do an antiderivative of something, or type in an integral somehow and get the answer. So this one is very conceptual in that you can't just Google how to do this problem. Because of this strange graph that you have here, you really have to understand it. So my point is, this would be probably a really good one to study and make sure you know how to do before you take your exam this year. So we have this graph, and it tells us here that this is the graph of f. So the introductory paragraph says that there's a continuous function f, which we're looking at, is defined on the closed interval from -6 to 5. It's a closed interval. So when I see closed interval, I start thinking EVT. They're probably going to ask me a min or a max somewhere in here. The figure above, or it's actually to the left on mine, shows a portion of the graph of f, just a portion of the graph. See, the graph is defined from -6 to 5, but they're only showing you the graph in the closed interval from -2 to 5. So you're missing part of the graph. But the part you see consists of 2 line segments. Now there's a reason why they're telling you that these are line segments. My guess is somewhere along the way, we're either going to have to find an area or a slope. That's why they're being very distinct with you that these are straight lines, so that you know if you need area, you're going to have some triangles formed there because those are straight lines. If you need a derivative of f, like an f prime, these are, you know that the slope of these lines you can figure out. So there's a reason why they're pointing out to you those are 2 line segments. That's going to be important. And a quarter of a circle. So right here is a quarter of a circle that's centered at the point 5,3. So here's the center of that circle right here. So we can see that the radius of the circle is 3 because the distance from here to here is 3 and from here to here is 3. So this is the quarter of a circle of radius 3. It's also known for some reason that the point 3, 3 minus radical 5 is on the graph of f. So that's this point right here. For some reason, they're telling you that y coordinate is 3 minus the square root of 5. Now that sounds to me like kind of an initial value kind of thing. Somewhere along the line, we're going to have that information. Now the 0.53, the point there really is only to point out to you that the radius of this circle is 3. So my guess is we're going to have to find an area of that quarter circle somewhere. All right, so let's go ahead and start reading the questions. So A says, if the integral from -6 to 5 f of x dx is equal to 7. So the integral from -6 to 5 would be the area under the curve of f of x from -6 all the way to 5. I can't see from -6 to 5, though. I can only see from -2 to 5. But that whole area is 7. Now, it says find the value of the integral from -6 to -2. Hey, that's the part we can't see. So they're telling you that the entire area under the curve from -6 to 5 is equal to 7. You can see the graph from -2 to 5. What they're asking you is, what's the area under the curve of the part of the graph you can't see? Well, now when I look at what I can see, if I do the integral from -2 all the way to 5, that would be this area that I'm shading with my pencil right here. If I find the integral from -2 to 5, that would be this area under the curve from -2 to 5. Well, I can find that area. Now I have to think about, what do I know about integrals? If the integral from -6 to 5 is f of x is 7, here's what I know. The integral from -6 to 5 f of x dx, if I break that into two integrals and add them up, that would be the same thing. So I'm going to break it up into the integral I can't see, which is -6 to 5. I'm sorry, -6 to -2. That's the part I can't see, f of x dx. And if I add to it the integral from -2 to 5 f of x dx, see, those two integrals together would equal the entire integral. And the part of the integral that they're asking, this is what they're asking you for. And you can find this because you can get the area from -2 to 5. But you know that this entire integral is equal to 7. So what I have really is a little algebra equation. This is unknown plus this is known, and it equals 7. We need to find this integral right here. So we're going to integrate from -6 to -2 f of x dx plus, and right here we'll figure out what the answer to this integral is, and it equals 7. So I just need to evaluate this integral, the integral from -2 to 5. Now notice it says show the work that leads to your answer. So you would want to say in your work, now I'm figuring out the integral from -2 to 5 f of x dx, and show yourself getting that, and then you're going to insert that answer right up here. All right, let's go about the business of doing that. The integral from -2 to 5, that's just a little geometry. We're going to find the shaded area. Let's do it one piece at a time. So first this piece. Well, that's a little triangle. The base is 1 and the height is 1. So that would be 1/2 base times height. Now this area, now be careful there, that's under the x-axis. This is going to be a negative area. Now look at this triangle. It's 1/2, the base goes from here to here. You need to figure out how long it is from here to here, so you need to know where this point is. Now if I just eyeball it, it looks like it's at 1/2, but don't guess. You need to know that that's 1/2. Well, that's why they told you this was a straight line. Look at the slope of this line. Up 2, forward 1. Up 2, forward 1. The slope of that line is 2. So see, it's 2 over 1. So if I go up 1, forward 1/2, wouldn't that be the same thing? Up 1, forward 1/2. 1 divided by 1/2 would still be 2. So that indeed is at 1/2. You just want to verify that, don't just guess. So the base is 1.5 or 3/2, and the height of the triangle, the altitude is right here, it's 1. Now you're going to subtract this area because it's beneath the x-axis. 1/2, the base is 3/2 times the height was 1. Now let's continue on. The next shape I see is, I see a triangle. Here's here's the height, and here's the base. So the base again goes from 1/2 to 2, so that's 3/2 again, 1.5. And the height is 3. So I'm going to add 1/2. The base was 3/2, and the height is 3. Oh, sorry. I got a cat in here, and she's trying to get right in the middle of everything. And the height was 3. Now I have to find this area. Now here you have to be a little creative and use your geometry brain. So if you want to find this area, remember this was a semicircle. So I'm going to turn this into a square. So right here, notice this is a 3 by 3 square. The area of this entire region would be 9. But then you have to subtract the quarter circle. So the whole thing is 9, and then subtract the part that's not shaded. That's this quarter circle. So the area of a quarter circle is 1/4 pi r squared. Now remember, the radius was 3, So the area of the entire circle would be, sorry about that, would be 9. So that whole is 9 minus, and then the area of the, the area of the entire circle would be what? 9 pi, pi r squared. 3 squared is 9, but you have to divide by 4. So 9 minus 9 pi over 4, that would be this shaded area. It's the area of the square minus the area of the semicircle. That is the area of this pencil shaded region right here. I'm going to add that as my final area over here. So now I'm going to add 9 minus 9 pi over 4. Now all that's left here is a whole bunch of arithmetic to finish this up. So let's see what we have here. That's going to be 1/2 times 1 times 1 is 1/2 minus 3/4 plus 9/4 plus 9 minus 9 pi over 4. So this 1/2 is really what? 2/4? So you have 2/4 minus 3/4, that's negative 1/4 plus 9/4 is 8/4. 8/4 is 2 plus 9 is 11. I get 11 minus 9 pi over 4. So the shaded area, which is the integral from negative 2 to 5, is 11 minus 9 pi over 4. Insert that right here, 11 minus 9 pi over 4. Now what you really have is an algebra equation. This is what you were looking for, plus this value is equal to 7. So you're just going to subtract this 11 over to this side, and you're going to add the 9 pi over 4. And this is your answer. So you get 9 pi over 4 minus 4. 7 minus 11. So this would be your answer for part A. Now you'd have a little more room on the exam. I got a little scrunched up there with trying to fit it all in the space, but you would have plenty of room on your exam. Of course, on your exam this year, you can use your own paper to write it all out, so you would have all the room you needed to write all that work in there neatly for them to see. So 9 pi over 4 minus 4 is my answer. That's worth 3 points, but I'll post the rubric so you can see how the points play out. All right, on to part B. Part B is the integral from 3 to 5. So I have 3 to 5, and it's 2f prime of x plus 4 dx. Here they're just trying to see if you, again, you know the properties of integrals, which you kind of needed up here to break up that integral from negative 6 to 5. So if you're integrating a sum, you can break that into 2 separate integrals. So you're going to do the integral from 3 to 5 of 2 f prime of x dx plus the integral from 3 to 5 4 dx. And another property of integrals, when you have a coefficient in front of your function, you're allowed to put that out front. So that's 2 times the integral from 3 to 5 f prime of x dx plus the integral from 3 to 5 4 dx. And now you're just going to evaluate those integrals. Hey, first this one. Okay, here's another concept they're testing you on. This is the fundamental theorem of calculus part 1. In your foldable you wrote the integral from a to b f prime of x dx is equal to f of b minus f of a. So the integral from 3 to 5 of f prime of x dx is 2 times f of 5 minus f of 3 plus, now do this integral, the antiderivative of 4 is 4x, and you're evaluating from 3 to 5. Now you know the answer to both of these, f of 5 and f of 3. You're looking at the graph of f. Those are just points on the graph. So f of 5 is this point. Hey, that's just 0. F of 5 is 0. And f of 3, oh, now you know why they told you that up here. You know f of 3. It's 3 minus the square root of 5. So here, and we're running a little bit out of room here, so let me get a clean sheet of paper and put it here to cover up this work so we can see the work. So we're going to be doing 2 times the quantity. Okay, first f of 5 was 0 minus f of 3. F of 3 is, let me get it from here, 3 minus the square root of 5. Plus, and then here 4x, plug in the top, 4 times 5 would be 20, minus, plug in the 3, 4 times 3 would be 12. So that's just top minus bottom, fundamental theorem again. So this is 2 times, now be careful, that 0 is going to distribute, so that'll be a negative 3 plus a square root of 5. And then I have plus 20 minus 12. Now right here, on your exam, you're going to have very limited time this year. You can stop right there. You do not have to finish this arithmetic. This is not an arithmetic exam. It's a calculus exam. So once you get down to all numbers, and actually I could have stopped back up here, you do not have to finish the arithmetic. Now if you did, I'm going to show you what you're going to get. You get negative 6 plus 2 radical 5 plus 20 minus 12. So 20 minus 12 is 8, minus 6 is 2, so I get 2 plus 2 radical 5. And in the interest of time though, you could have stopped right here and not finished. In fact, I suggest you do that or consider doing that on your exam to save time, because you're going to have very limited time this year on your exam. You have to submit the question before time expires, or they're not going to take your question. So I would stop there unless you're done and you have time to do it, but I certainly wouldn't. Plus, what if you make a mistake? So I would just stop. All right, so that's part B, and that's just properties of integrals. Now part C. The function g, a completely different function now, is given by the integral from negative 2 to x f of t dt. They want the absolute maximum of g on the closed interval. Notice the equal signs from negative 2 to 5. Justify your answer. That's EVT. So I know it's EVT because it's absolute on a closed interval. The closed interval is my huge clue that they really want me to do EVT when I do this problem. So on part C, I'm going to be doing that EVT. So when you do EVT, remember, you have to figure out what g of negative 2 is and what g of 5 is. Those are the endpoints. So do g of negative 2 and do g of 5. But then you also have to test any point on the interior that's a critical point. A critical point is anywhere where g prime is equal to 0 or undefined. Do we know what g prime is? Well, if g is the integral from negative 2 to x f of t dt, the fundamental theorem of calculus part 2 says that g prime is equal to, now remember how to do the derivative of an integral, you ignore the negative 2 constant on the bottom and you merely plug the x in for the t. G prime is f of x. In other words, this graph of f is actually g prime. So a critical point is where g prime is equal to 0. I would include that in my work because sometimes that's a point. It'll say, considers g prime equals 0. So I would write g prime equals f so that they know you know what f really is, and then write g prime equals 0 at x equals, okay, let's take a look. Where does g prime equal 0? This is g prime at negative 1, 1/2, and 5. So that would be at negative 1, at 1/2, and at 5. Now you're looking for an absolute max. Well, you were already going to check 5, right? You were already going to check 5 right here. Now, do you need to check both negative 1 and 1/2? Well, think for a second. What is a maximum? What constitutes a max? Here's what a max looks like right here. If this is g, g prime would be 0 at a max, but g prime would also have to be changing from positive to negative, because a max is where g is changing from increasing to decreasing. g is changing from increasing to decreasing when g prime is changing from positive to negative? Well, look at your graph of g prime. In your graph of g prime, this is g prime is changing from positive to negative at -1. -1 could be a max. But at 1/2, g prime is changing from negative to positive, which means g is changing decreasing to increasing. That's a min, not a max. I wouldn't even check 1/2. I would list it here, but I wouldn't check it. But I will check g of -1. Now, if you check g of 1/2, no big deal. You're still going to get full credit. It's okay to check something extra. It's not okay to not check enough, though. All right, let's see what we know. Well, we know g of 5. Do we know g of 5 already? Yes. And we know g of -2 pretty easily. Let's go from the top. G of -2. Well, if g is the integral from -2 to x, g of -2 means plug -2 in right here for x. That'll be the integral from -2 to -2 f of t dt. Well, that would be 0. If the upper and lower limit are the same, the answer to the integral is 0. I doubt that's a max. All right, g of -1, that's going to be the integral from -2 to -1 f of t dt. So that would be the area under the curve from -2 to -1. That's this area right here. But don't we already know what that is? We already figured that out. Back up here in my original work, right here, it's 1/2. So I already know that area. But I already know g of 5 too, because that means plug 5 in for x right here. That's the integral from -2 to 5 f of t dt. Well, don't we already know that in part A? We figured that out right here. The integral from -2 to 5, and we did all that area and figured it out. That's 11 minus 9 pi over 4. Now the question is, which one of these is the absolute max? Now make sure you answer the question. It says find the absolute maximum value. That means one of these three. They don't want to know where it is. They want to know what it is. One of these three numbers is the answer. Well, it's definitely not 0. Now, which one of these two is bigger? Now, you just kind of estimate it. 9 pi over 4. Well, think about what that is. So 9/4 is what? A little more than 2, right? That's like 2.25, 2 1/4, times pi, let's just say, is around 3. Okay, it's a little more than 3, but it's right around 3. Well, 2.25 times 3, that's a little more than 6, but it's less than 7. Let's just say it's 8. Let's just say it's 8, whatever. It's not that big of a number, right? So let's just say it's 8. We'll just pad it a little bit. 11 minus 8 is still 2. Even if it was 9, it's still going to be more than 1/2. So this number is greater than 1/2. This then would be your absolute max. Now I like to write absolute max by EVT. You're not required to write by EVT, but hey, why not show off when you know that's what you're supposed to be doing? Then it's crystal clear that you know what's going on. And so my answer is the number 11 minus 9 pi over 4, because they wanted the value. Now, last one is this limit down here at the end. Now, whenever I see a limit, my first thought is L'Hopital. So let's see what happens. And go ahead and plug 1 in. I usually do it in my head before I commit to writing anything. So 10 to the x will be 10 to the first, which is 10, minus 3 times f prime of 1. I need to know f prime of 1 right here. We'll come back up here. I've already figured that out. This is a graph of f, remember. F prime would be the slope of the f graph. At 1, I already figured that out before when I was talking about how I knew this point right here was 1/2. So the slope of this line is 2, so f prime of 1 would be the slope, 2. So this will be 10 to the first, which is 10, minus 3 times 2. That's going to be 10 minus 6. That is not going to be 0. This is not going to be L'Hopital's rule, strangely. So now I'm going to commit to writing, because I already know it's not L'Hopital, because L'Hopital is when you get 0 over 0. I'm not going to get 0 over 0. So it's going to be 10 to the first minus 3 times, and I just figured out that f prime of 1 was 2. divided by, now this is going to be f of 1. Well, this is the graph of f. F of 1 is just the point. F prime of 1 is the slope at 1. F of 1 is the point at 1. F of 1 is right here, 1. So f of 1 is 1 minus, the arctangent of 1. The arctangent of 1 means at what angle does the tangent equal 1? That's pi over 4. That should be memorized. The tangent of pi over 4 is 1 because sine and cosine are equal at pi over 4. And tangent is sine divided by cosine. And so now I have 10 minus 6 over 1 minus pi over 4. So that's going to be 4 over 1 minus pi over 4. You are not expected to simplify that. In fact, you could have stopped right here, or you could have stopped right here. You could have stopped at any of those because remember, arithmetic is not required. Now, as I look back at this problem in a whole, this again is a really good question for what they're going with this year's exam. Since you only have 2 FRQs and they want to test as much as possible, think about all the concepts that you've shown you understand when you did this problem. You've shown that you know the difference between when to get the area under a curve, when to use the slope, and when to use the point. So you've shown all 3 of those skills. You did area in part A. You did both point and slope here in part D. You showed fundamental theorem of calculus part 1 when you evaluated this integral. You showed fundamental theorem of calculus part 2 when you did g prime equals f. Think of all the things that this question tested on. This one I think would be a really good one for this year's exam. So you want to make sure that you know how to do every part of this question.